Hello, myself Naveen Kumar Saini in the course Wireless and Mobile Communication, code KEC 076. So today we are going to discuss about the fading, which is very prominent and important topic in the wireless communication system. So these are the contents which we are going to discuss about the fading and the different types of the fadings, which will cover in the two broad classification: large scale fading and the small scale fading. So before going into the classification of this fading concept, we must know what is actually fading is and how it affects in wireless communication system. So in wireless communication system, basically fading is it detroit the signal which is transmitted by the transmitter, and it will receive at the receiver with very less signal strength. Okay. So in that, the variation, time variation of the received signal power due to the changes in transmission medium or the path is called the fading. So in short, in the attenuation in the signal which is transmitted from the transmitting antenna, it is detroit and it passed through the different paths in the system, in the environment. So it will cause the signal strength reduction. So there are different impact of fading. So these impacts occur due to the environment. So that condition may be environment or atmospheric conditions, which comes through the rainfall and lightning, geographical position, time and radio frequencies. So in this picture we can see that in the transmitting antenna, when it transmits the composite signal with the different composite angle spreading, so in that case it passes through different paths. So this is the per path angle spread. So it shows the how this signal which is transmitted from transmitting, and it will receive from up to the any of the mobile station. So in that case it passes through the different paths and different obstacles occurs into the environment. So if one signal which is through the line of sight, so there is no obstacle between that, so signal strength will be good. But when it passes through the different obstacles like that, so it will follow the different paths. So when it follows the different paths with the which passing through the different obstacles, so in that case the signal strength will be reduced, or you can say the SINR value will be reduced. So these obstacles can be of the environment, rainfall as we said, and the buildings which is between the transmitter and the receiver. So there are different factors which occurs which depends on the which cause the fading. First is the fixed scenario. So in the fixed scenario, this fading depends on the atmospheric conditions and conditions such as the rainfall and the lightning. So in this case, so these things are fixed and the transmitter and the mobile is not moving. But when the mobile into the mobile condition, so in that case the fading occurs on the obstacles over the path which are varying with respect to time. So these obstacles create the composite transmission effects to the transmitted signal. So these complex transmission effects will reduce the signal strength, and this is nothing but the fading. So when we come to the point of fading, its type of fading, so in that the fading is classified broadly into the large scale fading and the small scale fading. So in the further classification of large scale fading, it comprises the path loss plus the shadowing. So these path loss and shadowing, these effects cause the large scale fading, which is for the long distance from the transmitter to the receiver. Second kind of or the classification of fading is the small scale fading, which is further classified into the two parts. First one is the multi-path delay spread, and second one is the Doppler spread. Okay. So as we are aware about the Doppler spread, this is when the transmitter or the receiver or both are moving. Then this multi-path delay spread is again classified in the two parts, where the flat fading and the frequency selective fading. And the Doppler spread, it is classified into the two parts, fast fading and the slow fading. So these are the broad classification in deep about the fading. So how the signals will be destroyed when it pass into the environment, in the wireless environment. So what are different types of the fading will occur? So it depends upon the distances. Suppose we have the long distance communication. So in that case, the large scale fading came into the picture. When there is a distance between the transmitter and the receiver is very less, so in that case the small scale fading come into the picture. So for the classifications we have already classified here: path loss, shadowing, then the multi-path delay spread, and the Doppler effect or the Doppler spread, then further classification of flat fading, frequency selective fading, and the fast and slow fadings. So these are the complete classification of the fadings. Okay, so one by one we will discuss about the different types of fading which attenuates the signal power, right? So this fading is majorly due to the multipath. Okay, as follows the scenario. So because multipath means when any signal, this signal copy is transmitted and it follow the different paths. So this is transmitted from here, it will reflected from the home, clouds, trees, buildings. So after as it passed through the different mediums, so in that case this was a transmitted sinusoidal signal. When it is received at the receiver, it will be destroyed in nature. So this detroit or attenuation occurs into that signal. So this effect is called the ISI, inter-symbol interference, at the receiving side. So this deterioration or reduction of the signal strength is called the fading. So I hope this concept is clear to you. So as we have started the different types, so first one is the large scale fading. So in that large scale fading, the attenuation of the signal power due to the obstacles for the radio communication or the long distance. So in the wireless communication system, when the transmitter and receiver both are in long distance, so in that case of fading which occur due to the path loss or the shadowing effects into the environment, it causes the large scale fading. Second one is a small scale fading. So this is the fluctuations in the signal strength and phase over for the short distance. Okay, for the short distance and small duration of the time. This is a very, very important point. For the short distance and for the small duration of time, so fluctuations of signal will occur. So as it is passing in the meters or in few meters and so on, so in that case the signal strength will be affected a lot. Fluctuations will occur just like this. If this is a very short distance, suppose, so in that case these fluctuations of the signal is causing the signal strength reduction. So we call it the for small scale fading. So let's elaborate more about the large scale fading. So in that, as we said, in the large scale fading is nothing but is a combination, or you can say this is the part which comprise the path loss. So this path loss we calculated into the free space form, and we take the logarithmic scale to find the path loss in the dB. Okay, so in that log normal scale is used to calculate the average attenuation in exponentially proportional to the distance, right? So plus shadowing. So this is the shadowing which occurs when we have the this issue occur when we have the obstacles like buildings, trees between the transmitter and the receiver. So in this way, this is called the shadowing. So these are secondary wavelets wrap around the large obstacles. So in that way we see these are path loss effects. As the time passes, the signal level will be reduced, and here because it shows this kind of signals, so some ups and downs. So why it show? Because when we receive the signal at the receiver, so it passes through the different obstacles between the transmitter and receiver. So when the multiple copies of the signal is received at the receiver, so after the reception, the signal strength may be reduced or increase as well. Why it is so? Because when the signal copies are received in constructive manner, right? So it is constructive manner, the signal strength will be increased. If the addition of the received signals are in destructive manner, so in that case the signal strength will be reduced. So large scale fading, mainly these are two effects as we said. First is the path loss, and second one is the shadowing. So this is called the large scale fading concept. So there are the different mitigation techniques which are used for the large scale fading, which includes the power. By the power control we can reduce mitigate the large scale fading. Power control means as per the requirement. If the environment is clean, so in that case we can transmit, or the LOS is there, then we can transmit, we can pump or we can transmit the signals with the high power. If the environment is rainy season or the foggy is there, in that case we can reduce the power. So it means the power control techniques can be applied to reduce the large scale fading. Antenna placement is there. So based on our requirement of the application or the environment or the size or coverage area, so as per the requirement we can use the antenna into a particular place. Repeaters can be used to enhance the power signals and the site diversity. So we can transmit the more multiple copies of the same signals so that we can diversify the signals. Okay. So in the small scale fading, so small scale fading is nothing but is the multipath fading or the multipath propagation. So in that the stationary object is there, line of sight is there, and LOS is there. It simply, when the transmitting antenna or the base station is transmitting the signal to the user which is into the car, then this signal copy can be come from the line of sight, it can come from the after reflection of the secondary object, or it can again reflected by the major objects. It depends. All the effects will occur like reflection, diffraction, scattering. So these are the effects which occur or influence the fading or the signal strength, and the small scale fading will occur. Doppler shift causes by the angle of arrival related to the motion of the receiver. So it means if the receiver is in the motion, okay, so in that case the Doppler effect will occur. If any of the base station is kind of like that, it is also moving or both are moving, then the Doppler effect will occur. So the main reason for that is first is the random frequency modulation due to the varying Doppler shifts on the different multipath signals. Fine. Second is time dispersion echoes, which is caused by the multipath propagation, delays due to nearby objects. Third one is movement of sounding objects. This is very harmful. When the sounding objects is also moving, then it is very tough to collect the signals or receive the signal efficiently. So it is desirable that the obstacles must be kind of stable or the fixed, right? But it is not always possible. When the your transmitter or the receiver is moving and the obstacles are also moving, in that case the small scale fading will affect the signals very sharply. So delay spread, so it is a direct signal which is transmitted, and this is the reflected and delayed signal which is or reflected by the different obstacles between the transmitter and receiver, kind of buildings, trees and so on. And then this is the output or the resulting received signal showing the multipath. So okay, so when it is transmitted, so this is the original signal which is transmitted, and this one is reflected. When we combine these signals, so obviously at the receiving side, maybe at a destruction or maybe as a construction, the signal strength will be increased or it may be decreased. So in that way the received signal will be detroit in nature. So measuring access delays, so there are some of the parameters for the delay spread which needs to be known to us. So there's some finite delay between the time at which the antenna receives the first copy of the signal on the shortest path and that at which it receives the last copy of the same signal on the longest path. So simply if we want to know this delay, so this will be complete time, total time minus z naught, tau naught. Okay, so this is a delay. when the last copy is received, tau t, and z tau 0. So it is the nothing but the when the first copy of the same signal is received. So this delay is we need to be calculated. So the maximum delay time spread, it is the total time interval during which the reflections with the sufficient energy arrives. And second is the root mean square delay spread. So it is the standard deviation of value of the delay of the reflections weighted proportional to the energy in the reflected waves. So this is a root mean square delay spread. So intersymbol interference, which is due to the delay spread, it shows that this is the multiple copies of the same signals. So d t minus tau naught ISI results in the bit errors. So it shows at the time tau naught or tau 1, tau 2. So these are different time intervals at which the same signals is transmitted. So when the same signal which is transmitted from here, so when these signals are combined, so after the combination, what occurs? So this is the signal which we are getting. Okay. So what it shows, this is the intersymbol interference, because if these are transferred or transmitted at different time intervals, so when we combine at the receiver, so this will combine, so this section will combine all together, this section will combine all together, this section will combine all together. So when we combine all these things, then the signal will be like this one. So ISI of the signal will occur, because the original signal which we must got it, this must be in the square or rectangular wave shape. So there are different ways to reduce the ISI, intersymbol interference. How to reduce that? So for that one, we use the orthogonal frequency division multiplexing. So OFDM techniques are used to reduce the ISI by using the cyclic prefix. Okay. So it's also possible to remove the intersymbol interference between the different symbols using a filter that is called a Nyquist zero ISI. So there are two methods. Third one is, it's possible to manage ISI by controlling the transmission rate. So by this way also we can control the ISI. So there are the three different methods or the ways by which the ISI or intersymbol interference can be reduced. First one is the using the OFDM signal, OFDM. So OFDM is used to reduce the frequency selective fading. So what happens in the OFDM? It will convert the frequency selective to the flat fading. So by which the ISI can be reduced. Second one is by using the filter, that is the Nyquist zero ISI filter, or the criteria can be used to reduce the ISI. And third method is we can control the transmission rate by which the ISI can be reduced. So some of the definitions are there. First is the coherence time. So for that, the definition for this one is the coherence time with bandwidth. So this coherence time or the coherence bandwidth, these are the basic references by which we can find or calculate how this signal will be destroyed or not, or the channel is destroyed or not. So for coherence bandwidth, this is a reliable communication system without using the adaptive equalization or other multipath techniques. The transmitted data rate may be much smaller than the inverse of the RMS delay spread. Okay, that is called the coherence bandwidth. So this is the definition. So channel transfer function remains virtually constant over the coherence bandwidth. So what is the meaning of this? The coherence bandwidth, what happens when we transmit the signal whose signal strength, whose bandwidth is less than the coherence bandwidth? In that case, the same signal can be received at the receiver without deterioration. Suppose the signal is bandwidth of the message signal is greater than the channel bandwidth. So in that case, the signal will be destroyed. So what is that reference bandwidth? That is the coherence bandwidth. Then we have the resolvable paths. So wideband signal with the symbol duration TS. So in that we use the signal sequence, that is the DS CDMA signal, with the chip time T chip, that can be resolved the minimum dispersion of the channel. So this is the resolvable path. So that accuracy can occur by about the TS, which is the symbol duration. And DSCDM में the number of resolvable path is NP, round figure of this value, T delay divided by the T chip plus 1. So this is the formula simply to find how many resolvable path is there through which, or select that resolvable path so that the signals can be transmitted easily and it can be received at the receiver properly. Then we have the Doppler shift. So Doppler shift occurs when the vehicle is moving with some of the velocity, and because of that movement, that in that case the received signal will be detroit. Okay, because the transmitting antenna or the base station is transmitting the signal, it is passing through the different buildings, or some kind of interferences can occur, right? So we can see like this. So it will receive at different phase or different angles at the receiving side, and the Doppler effect will occur. So the classification, when we talk about the small scale fading, so this classification is mentioned here. So how it is classified? So based on the multipath time delay spread, small scale fading is classified in the two parts, flat fading and the frequency selective fading. So what is the condition for the flat fading? So flat fading is what? When the bandwidth of the signal, we can say this is the BS, if it is lesser than the bandwidth of the channel. Okay. So when this condition is there, then the flat fading is there. So what is the meaning of the flat fading? It means all the frequency components will be affected equally. It's not like that selective part of the frequency component is affected. But in the flat fading, what happens? Thus, all the frequency components of the signal will be affected equally. So this is desirable, in fact, basically we can say. So based on that, we can use the different mitigation techniques for the remove the fading. Second condition for that is the delay spread. So that is the delay spread, we can say, is less than the symbol period. So this is, we can say, as a T. Okay. So when the delay spread, that is the tau s, is less than the TS, that is the symbol period. So this is the case for the flat fading. Second part is the frequency selective fading. Second classification of the small scale fading. So in that, this is the opposite of the is this one. The first is the when this signal strength, if the bandwidth of the signal is greater than the bandwidth of the channel. Obviously, so when the signal bandwidth is greater than the channel bandwidth, it means it will not pass properly. When we have any kind of pipe and we of some diameter, if we use the very large diameter data to put into that fiber or into that pipe, so it cannot be passed properly, right? So the size of the data or the anything which is passing through that pipe must be lesser than that. Then only this signal can pass properly. Okay. So this frequency selective fading is not desirable properly. It's not desirable in the wireless communication system. So first condition is BS must be greater than BC, and delay spread, that is tau s, is if greater than TS. So this is the case for the small scale fading by considering the multipath time delay spread. Okay, when the transmitter and receiver both are stationary in nature. Now when we have the Doppler effects come into the picture, when the moving obstacles or the moving transmitter receiver is there, then small scale fading is classified into two parts. First one is the fast fading and second one is the slow fading. So what is the condition for the fast fading? So this is a high Doppler spread is there. It means when the motion of the obstacles are very high, so in that case fast fading will occur. So high Doppler spread, the coherence time is less than the symbol period. Third one is the channel variation faster than the baseband signal variation. When the channel variation is large as compared to the signal variation, so in that case the fast fading will occur. Then we have small scale, slow fading, sorry. So slow fading is what? When this is of the slow or the low Doppler spread is there, it means the obstacles are moving with very less velocity. And then second is the coherence time if it is greater than the symbol period. So in that way this slow fading will occur. And third one, channel variation, it is smaller than the baseband signal variation. So these three are the cases for the slow fading, and for the fast fading we have like that. So this is this occurs slow and fast fading. It is based on the Doppler spread which occurs due to the motion of the obstacles between the transmitter and receiver. So I hope this point is clear to all of you, this classification. So in short, I just want to explain again that for the large scale fading we have the shadowing and the path loss, and in the small scale fading these are classified in the two ways. First one is by considering the multipath time delay spread, and which is classified in the flat and frequency selective. Then we have small scale fading, fast and slow fading. Then different definitions we have just said that in small scale fading is generally called as the Rayleigh distribution. Okay, so which occurs when the symbol period of the transmitted signal is much larger than the delay spread of the channel, and bandwidth of the applied signal is very narrow, so which may cause the defects which increase the transmitted power. To combat this situation, okay, so this is the solution for the flat fading concept. Similar to that, these conditions we have already explained about the flat fading when the Bs is less than the Bc and the Ts is greater than the, where we have mentioned the tau s, but here is the sigma tau. Okay, coherence bandwidth, signal bandwidth, symbol period, delay spread. So frequency selective, which is very harmful in the wireless communication system, and conditions we have already explained about the frequency selective fading. So this frequency selective fading can have to be converted into the flat fading. So or we can say frequency selective is very much affected by the ISI, and how to reduce this frequency selective. So this frequency selective can be converted into flat fading by using the OFDM signals. Okay, so these are the conditions of the frequency selective fadings. Fast fading, as we said about these conditions, this is already mentioned about the, it is related with the coherence time which can be reduced by using the different characteristics or different methods. Then slow fading, again the rate change of the channel characteristics which is smaller than the rate of change of the transmitted signals. So these are the comparisons between the small scale and the large scale fading. So how these are the different parameters by the time variation, cause, distance, frequency, spatial variation, typical scale effect on signal mitigation techniques which were used. For the small scale, equalization, diversity, adaptive modulation is used, and for the large scale, power control, antenna placement, repeater side diversity is there. Rest you can go through, which we have discussed already about the comparison section of small scale and large scale fadings. So these are the reference books which I have taken care of. About first is the Rappaport and the Open Dalal. So thank you very much. I hope you understood about the fading. Okay, thank you.